Hi, we're the IUPUI Student Design Group 3, Remote Spectrum Analyzer. My name is Jeff Schoenberger.
I'm Jeffrey Luke Burnett.
I'm Ben Reimer.
I'm Josh Reynolds. The purpose of this project was to design a system so that an end user could view radio spectral activity from a remote location, using either an Android client or a PC Linux client.
The requirements for this project are as follows. Separate clients designed for the Linux and an Android tablet. The clients can remotely control the server. Server and clients communicate wirelessly on a local network or over the internet. Clients will plot the RF spectrum in real time in the magnitude view. There will be a 25 megahertz bandwidth, latency will be minimized, and the amplitude will be within 1 dB of accuracy. Compression and decompression of data between the server and the clients will happen in real time, and packet loss should not affect performance.
Okay, so here we have the client app that's on the Linux. The Linux-based client app that's built using Qt. It's only one screen that comes up when you start the app.
Yeah, you work with PA?
So down here you basically enter the IP address of the server. Right now it's 92.168.2.104. And you go and hit the connect button. And now we're connected. So basically over here on the bottom right side are the options that you can choose. You can turn the data stream on or off.
Alright, well, yeah, take it easy, man.
And then you can adjust what you want your center frequency to be. So if we go to
I'll catch you later. I'll see you tomorrow.
460, I hit tune.
Oh, okay. We might still be
Immediately jumps up to 460. And this is the band where the GMRS, FMRS radios are, which I've got one right here. So if we go ahead and key it up, you can see it coming in really strong because we're right next to the antenna.
And Josh, what channel are you on for your radio?
I'm on channel 9.
Okay, so I'll switch to a different channel.
And you can see that's...
So I'm pressing mine in now. I'm on a slightly different channel than Josh. I'm on channel 6. And then Josh, you should be able to hit yours, and we should... Yeah, so you can see both peaks.
If I go ahead and disconnect the antenna, since we're so close, we might be able to actually see it better.
Might be better.
Yeah.
There, so here, I'll flick my button on and off. And then Josh, so you can see where we're getting both radios in here.
Right now the frame rate is fixed, I think around 15 frames per second. Some of the other options, you can adjust the bandwidth from 25, 20, 10, and 5. Maybe less or more of the spectrum. And then also you can adjust down here the number of FFT points that the server will send you. Away from 8192
Frame rate drops
down to 1024. I default to 2048. And so that's basically all there is right now to the Linux-based client. We just wanted to show you real quick what the server app looks like. Basically, when you just pull it up, there's this one screen. Right now, it only works with the USRP, and the USRP has to be connected before the app will start successfully. So when it comes up, the only option that you have is to select which IP address you want it to listen on. And these are basically the 3 network adapters that are in on the Linux machine. You can listen for the client on the local host. This is the Ethernet adapter, and this is the wireless adapter, right? And it dynamically finds those on startup. And then it just shows you what port it's listening on. Right now, which is hard-coded to always listen on port 50,000. And then this right here is showing you that the client is currently not connected. So over on the client side, if I connect, it'll then pop up with the IP address of the client that's currently connected. And if on a client I turn the stream on, down here you can see the data rate. The top one is representing the input rate, and the bottom one's supposed to be the output rate. Let's see if this will focus. Basically, the input rate is the data rate after the FFT has been taken and the data has been put into frames at the said frame rate that we want. at that point, the data is still being represented as floats, so it's basically the rate before any compression has been applied. This output rate is the data rate to the client. That's after the data has been thresholded, or the spectrum frame has been thresholded, quantized, and actually compressed. So right now we're achieving about a 10-to-1 compression ratio almost. Over on the client, the settings are a bandwidth of 25 megahertz with 2048 FFT points, and our data rate, I don't know if you can read it, is 104 kilobits per second. So that's what it's currently taking up on the network right now. That's all we had.
This is our Android client. From here, the user can go and select the center frequency, and they can also specify a bandwidth here. On both the center frequency and bandwidth, the user can also choose to scale for convenience. Right now, we're choosing to tune into 97.1 megahertz with a 25 megahertz bandwidth. The user can also scale the magnitude. Once you've selected these variables, you can hit the tune button, and as you can see, we were already tuned to that frequency. So now I will kind of move up a little bit so we can see something different. And that's the remote spectrum analyzer. I'm Jeff Schoenberger.
I'm Ben Reiner.
I'm Josh Reynolds.
I'm Jeffrey Lubernett.
Signing off.